Hi Geometry, this is Unit 5, Lesson 17, page 631 of our workbooks. If you could pause this video and give a little space underneath the writing in our workbook and write down example 1, and then come back to the video and we'll get started with the lesson. So welcome back. So let's take a look at 17.1. It says, which has more mass, 1,000 kilograms of feathers or 1,000 kilograms of steel? Think about that for a moment. Which one has more mass? Hopefully you were thinking, well, they both have the same mass. They both are 1,000 kilograms. They both have the same mass. They both weigh 1,000 kilograms. This is different. This is different than volume. Volume would be the amount of feathers that you need for 1,000 kilograms, which would be a lot of feathers, and the amount of steel which you need for 1,000 kilograms, which I don't know, it may not be very much steel that you need to make 1,000 kilograms. So this brings us to the concept of density. So in our workbooks, density of a substance is the mass of the substance per unit volume. We write density equals mass divided by volume, or in our work you'll see me write D equals M divided by V. So let's look at this example I asked you to write in your book. It says a rectangular prism with side lengths 3 centimeters, 5 centimeters, and 10 centimeters has a density of 12 grams per cubic centimeter. What is its mass? So in this problem, my unknown in my formula is M. So I'm going to use my formula, density equals mass over volume, to find the mass. However, I need the volume. I was given the side lengths, but not the volume. So here I do have a step 1 before I can get started. I have to figure out my volume. Well, the volume of a rectangular prism is length times width times height. So I know it's 3 times 5 times 10. So my volume is 150 centimeters cubed. Okay, so step 2. Let's plug that into my my density equation. So density in this problem, density equals mass over volume. And I'm going to keep my labels here. I want you to see how my labels are canceling. You don't always have to have your labels in your work if you know how to label your final answer. So in this case, my density, it says, is 12 grams per cubic centimeter. So my cubic centimeters in the denominator, my grams are in the numerator. So I'm going to write it as 12 grams over 1 centimeter cubed, or just my centimeters cubed, equals my mass, which I don't know, divided by my volume, which is 150 centimeters cubed. So to solve for mass, I need to undo it being divided by volume. So I'm going to multiply both sides by 150 centimeters cubed. 150 centimeters cubed. This is in the numerator, if you will. So it cancels my denominator on the right side. And my centimeters cubed just canceled on my left side. So when I multiply my 150 times 12 grams, I end up with 1,800 grams. So this would be the mass of that particular rectangular prism made of whatever substance had this density of 12 grams per cubic centimeter. Let's take a look at 17.3 on page 633 of our workbooks. An aquarium manager drew a blueprint for a cylindrical fish tank. That'd be kind of cool. The tank has a vertical tube in the middle in which visitors can stand and view the fish. Well, that's kind of exciting. The best average density for the species of fish that will go in the tank is 16 fish per 100 gallons of water, because we want our fish to be happy. So 16 fish per 100 gallons of water. That's actually a lot of space for these fish, I think. This provides enough room for the fish to swim while making sure that there's plenty of fish for people to see. The aquarium has 275 fish available to put in this tank. Is that the right number of fish? If not, how many fish need to be removed or added? So I'm not going to worry about the 275 until the very end. I need to find out how many fish can go into this tank. So I've got lots of steps here. First of all, it's good to know that there is 7.48 gallons and 1 cubic foot. I'm going to use that because if you notice, the dimensions for my tank are all in feet. So I've got a little work to do. I need to, if I'm going to work with my density formula, which remembers is mass over volume, I'm going to need my volume. So I've got a little bit of work to do for volume. So let's get started with that. So before I think too much about anything else, let's find that volume of this tank. So I'm going to find the volume of tank in, first, feet cubed, because that's what the dimensions I'm given. So first of all, I learned earlier in this unit that the total volume of this cylindrical tank is going to be the whole thing minus the missing inside part. So looking more closely at my dimensions, my cylinder's pi r squared h. So my entire whole thing would be pi times, notice this 2 feet plus this 3 feet. The entire cylinder shape has a radius of 5 squared plus times 4 for the height, minus the missing inside part, which has a radius of 2. So this is the pi 2 squared times that same height of 4. And so when I do my math, I get 100 pi minus, what is that, 16 pi? That would be 84 pi. And I'm going to go ahead and multiply because I need to use this number in further math operations. That's approximately 263.89 feet cubed. Depending on how you round, our numbers might get a little different from here on out. So that's the volume of my tank. However, I know that I need 16 fish per 100 gallons of water. I need to convert my volume. So step 2 in my thinking, I need to convert this volume to my gallon volume because I need to be able to reason it out with gallons. So let's think about this as dimensional analysis. I need to change my units from feet cubed to gallons. So let's convert. So I've got 263.89 feet cubed. And if I'm going to do my dimensional analysis, I know that I've got 1 foot cubed. I'm going to put that in the denominator so it cancels with my feet cubed in the numerator. And there's 7.48 gallons in that 1 foot cubed. So my feet cubed cancel. For my numbers, I'm going to multiply, and I get 1,973.9 gallons. Okay, great. So now I can really think about my fish per gallon. There is 16 fish in 100 gallons of water. So that is 0.616 fish per gallon, per 1 gallon of water. So if I have a total of 1,973 gallons of water, I'm going to take the number of fish, which I don't know what 0.16 of a fish is. That's kind of a weird thing to think about, huh? But I can fit 0.16 of a fish in each one of these gallons. So now my gallons are going to cancel. And it looks like when I multiply my 1,973.9 times 0.16 fish, I get 315.8 fish. So it looks like they need more fish. because up above they say they have 275 available. So if they can fit a total of 315, which really you can't have 0.8 of a fish. So you either need to go with 316 fish or 315 fish. I'm going to round up here, but I could completely see where you would think about rounding down to the nearest whole fish. So 316 minus 275 means that they would need approximately, give or take, 41 more fish for this tank. This tank's density is that it can fit about 0.16 fish per gallon, so I can add some more fish for my total number of fish in this display. Kind of an interesting problem. So let's take a look at the summary, please. So let's read this. Imagine you have a baseball, okay, that's a spherical shape, and an apple. Let's think about the apple also being a sphere. If it says that if we weigh each, they will likely find that although they're the same, the baseball weighs more. In other words, the same size, the baseball's going to be heavier than my apple. Okay. It says the baseball has a volume of 200 cubic centimeter and weighs 145 grams. So this is my volume, and this is my mass. While the apple has the same volume, so I know it's the 200 cubic centimeters, and it weighs 100 grams. That's my apple's mass. We say that the baseball's more dense, so let's not read anymore. Let's do it ourselves. Let's practice our density. Density equals mass divided by volume. So let's do our baseball density. Our baseball's mass was 145 grams divided by its volume, which was 200 cubic centimeters. So when I do 145 divided by 200 on my calculator, I get 0.725, and my label is grams per centimeter cubed. That's a density label. That's my density of my baseball density. That's how dense my baseball is. So let's do my apple's density. So let's figure out how dense my apple is. The density of my apple would be the mass, which is 100 grams again. It says it up above in the problem, divided by its volume, which it says it has the same volume. So 200 centimeters cubed. When I divide 100 by 200, I get 0.5, and my grams and centimeters don't cancel, so I have grams over centimeters cubed for my label. So this is more dense. The 0.725 is a bigger number, 0.7, and this is less dense, and that makes some sense to me. The apple has a lot of water in it. If I wanted to cut into my apple, it would be easier to cut into. It's less dense. There's more water weight in it. And so these two answers for density of these two objects make sense to me. Let's take a look, if you will, at the practice problems. Let's take a look at just some hints for practice number 1. First of all, this washer has an inner diameter. That's the empty space. So I'm going to show that in green right there. Diameter of 1/4 an inch. So first of all, you guys, the diameter then, let's change the 1/4 to 0.25. Put that in on your calculator. That gives me a radius of 0.125 when I divide it by 2. Great to know. And then it says the outer diameter measures, and I'll do this in a different color. My outer diameter measures 3/4 of an inch. So this is my outside diameter starting for the center all the way through. The diameter is 3/4 of an inch. So that would make my D 0.75. And if you divide that in half, it gives me a radius, sorry, I got to write up above, I ran out of room, of 0.375. So this blue radius is 0.375. It says the washer is 1/4 an inch thick. So let me grab my red for a minute. That's this thickness. This thickness is also 0.25 inches thick. It says the density of the metal washers that they're made to be 0.285 pounds per inch. So that's my mass per volume, 0.285 pounds per inch. How much do 5 washers weigh? So I can't even worry about the 5 until I know how much 1 washer weighs. So I'm going to be thinking about my density equals mass over volume. Here I'm going to be solving for my mass. I know my density, it's 0.285, and I can figure out my volume. So let's find my volume. So first of all, I need a little bit of space to work. My total volume, so the total volume is going to be equal to my whole thing minus the inside part. So when I calculate this, it's a very, 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 very short cylinder. So I'm going to be using pi r squared h for both my inside and outside parts. My radiuses, my radii, we've talked about up above, and my height is this thickness, which is the same for both. So you need to substitute in your numbers and find your total volume, which is actually a very, very, very tiny decimal. We're going to plug it into this equation for volume. We're going to plug my 2.285 in for my density, and you will solve for your mass. You're not done once you solve for your mass, which should be labeled in pounds. You need to figure out what 5 of them weigh in pounds. So when you solve the red equation, your density equation, your mass is going to be for 1 of them in pounds, and then you're going to need to find out what it is for 5 of them. Thank you very much.